Hello, fellow lazy chemists. Today, what we're going to do is have a brief little discussion on a topic that's going to be a fairly easy one. This is kind of like a memorization slash, just being able to read and um, figure out like the different types of enthalpy. And I say that it's memorization, but it's really just paying attention to see what kinds of enthalpy are involved in something, and then making sure that we're using the right kind of chart for it. Because in general, because we're chemists and we're lazy, we've already figured out enthalpies, or we've paid somebody to figure it out for us. So we just want to make sure that while we're figuring out a solution to a problem, that we make sure that we're using the right enthalpy information in order to figure it out. And today we're going to go over the different types of enthalpies that could be, so that you know which table to look at for your information at. Okay. So the first one that we're going to go over here is called the enthalpy of formation. Okay. And what's going to happen here is that these symbols here indicate what type of enthalpy is going to be involved. Okay, so this is a triangle. In this case, this is delta. It means a change in enthalpy, and this means at standard conditions. Okay, and just a second here. All right, and standard conditions, and I wish that I had put this in here. Just a second. So standard conditions means that this experiment is conducted in a standard laboratory setting, which means that it's 1 atmosphere. In general, we try to use 1 atmosphere because it's the easiest one. And then 25 degrees Celsius. Okay. So this first one, enthalpy of formation, is a change in enthalpy, so delta H. This F here means that it's for formation, and this circle will usually have a line through it, means that it's happening at standard laboratory conditions. And for standard enthalpy of formation, it's basically the amount of energy to create 1 mole of a compound from its base elements. Okay? And so this is saying like, oh, okay, it takes this much energy to convert carbon and oxygen together to make carbon dioxide. Okay? And we have a loss of energy right here. Okay? Our internal energy has gone down. Okay? And that's what enthalpy of formation is. And this is actually usually the one that you're going to use most often, okay, is the enthalpy of formation, because it's saying like, hey, this is the internal energy change of this particular compound. The next type of enthalpy tabulation that you may use is the enthalpy of reaction. In truth, this one is usually the laziest type of enthalpy because it's the entire reaction's already figured out. So, it's a useful one to have tabulated if it's already there. Again, you'll notice that we have delta H, which just means change in enthalpy at standard state, and R, okay? And this is the enthalpy of change that occurs as a result of 1 mole of reactants in a chemical of 1 mole of reactants, we should have reacting in a chemical reaction, okay? So here, this is just 1 mole. This reaction of going from ethanol right here plus oxygen ends up giving us this release right here. So every mole of this gas that we have that's being, burned, in this case, is going to be release this much energy right here. And you're always going to go with the lowest amount of moles. If it's saying like 1 mole of reactant, it's usually the smallest amount because it's 1 mole of this reaction going forward. Okay. Next, we're going to go ahead and have enthalpy of a phase change. Okay. So different phase changes are also going to require a different amount of energy. As an example, if we have our heating and cooling curves, this is just like a throwback to when we had these. Remember that when we had heat added, this is energy that's going into a phase change that's right here. And so we can go ahead and we have most of those tabulated, okay? And so here it's going to indicate what kind of phase change is happening, okay? So here I went the ones that were going, higher. We went with vaporization and fusion. And it's the energy required to achieve the phase change for 1 mole of a substance, okay? So, for example here, the amount of energy it takes to go through N2 at fusion at standard temperature and pressure is 0.71 kilojoules per mole, and to achieve boiling point, it only needs 5.6 kilojoules per mole, okay? And both of these are relatively small because N2 really wants to be a gas at room temperature. So just be aware, vaporization, fusion, you could theoretically have one where it, they say the change in condensation, but it's basically, reading this and being like, oh, okay, this is what's going on here. And recognizing that this is a change in energy because of this situation. I'm going to be perfectly honest. When I was in college and doing thermochem, though, this particular one was a type of enthalpy that when we had reactions that a lot of people missed and forgot. Just because if you're doing a enthalpy calculation and it has a phase change in the middle of it, people typically forgot to add the amount of energy that it took for the phase change. So just be aware of that as you go forward, that if there is a question that has or a process that requires the heating or turning of something into a gas, that you have to include that energy in there. Okay. Next is a special one. This is a enthalpy of combustion. And this is similar to the enthalpy of a reaction. The only difference is that it's specifically set for combustion instead of a reaction. So, I even use the same exact formula. Here, this is a reaction of 1 mole of this substance that is burned. And this is ethanol again, and it's burning with an excess of oxygen, okay? And so it's just tabulating here. So this is another type. Notice that enthalpy of combustion has a C attached to it. Okay. The next type is called enthalpy of neutralization. And this is, when 1 mole of an acid and equivalent amount of base have been neutralized. Okay. And, this is just an example, acid and base, and, it releases 57.9 kilojoules per mole. Okay. Most of these are, fairly simple to, determine here. Enthalpy of charge or change in solvation. This is when 1 mole of a solute is dissolved in a substance or into a solvent. Okay. And usually this one is written out for the actual ion itself. So you're going to have to remember that the ion, you'll have to go ahead and count how many ions there are in your amount there and multiply that through in order to make sure that you get the right amount here. And this is what solvation means. That just means that it's being dissolved in water. So be aware that when things are being dissolved in water, that they're going to go ahead and have amounts here. Though that seems quite large. Oh, yeah, I think I have it off by a level of 10. Oh, ooh, ouch, ouch, ouch. Yeah, it looks like this is supposed to be joules. Okay. So these numbers, it looks like I have joules. Just make sure that you're using the right amount. I think that these numbers here might be a little bit suspicious, but we'll move on from there. Just know that in terms of solvation, it's usually the actual ion itself that you're counting, and then you have to multiply that a couple of times. Next is enthalpy of atomization. Gonna be perfectly honest, I've never worked with this one. I wouldn't have any issues working with this one, but like I don't see this one all too rarely. And this is just where you take like a relatively stable compound that's in usually its ground state. And so this is H2. H2 is happy here, and you give it enough energy that it splits up into two independent atoms here. And notice here that this has actually taken an increase in energy, but it's basically the enthalpy of 1 mole of gaseous atoms that are formed into its elements. Okay, so this is enthalpy of atomization, taking a compound element like hydrogen gas and turning it into two independent hydrogens. Okay. And the last one is the change in hydration of a salt. So salts, when you hydrate them, are going to have a change in energy. And it's the same thing. It's 1 mole of a salt gaining in hydration. And yeah, that's our last one right here. This one should, this one I suppose that I forgot that we should have this right here. And there we go right there. All right. And that's the last for the types of enthalpies. Remember, this is just for making sure that when you look these up in a particular table, that you know what you're looking up and that you're accounting for all the different types of enthalpies that may be going on in a reaction. All right? Until next time, stay lazy, my chemists.